Hello everyone. Today our topic is analysis of uniformly tapering circular rod. Today our analysis about the circular rod, tapering circular rod. We have to analyze the stress, strain and the change in length for a tapering circular rod. Tapering circular rod. Let us draw a tapering circular rod. This is our circular tapering rod. Here the mm, uh, length of the tapering rod is L. Here the diameter, the tapering, let us assume that the tapering rod has two ends. One is left end and there is right end. In the cross section, left end cross section, diameter is D1 and the right end cross section diameter is D2. From the left end at a distance x, let us take an elemental strip elemental strip dx. Okay, this is our elemental strip. The cross section the cross section circular cross section also has some diameter. This diameter is dx. You can see that uh, the diameter that the diameter, if we consider 2 points here and here, the diameter along the length L varies linearly. Okay, diameter dx from left end to right end varies linearly. To show the variation, let us take a graph between diameter versus the length, that is dx versus length. of tapering rod. Graph of dx versus length, that is diameter of elemental strip, diameter of cross section of elemental strip as it is our circular, and versus length of the tapering rod. The graph will be like this. This is our dx, this is our length L. Along the length L, the diameter varies linearly. From left hand, let us take at left hand, this is x equals to 0, this is x equals to x, and this is x equals to L. Okay, from at x equals to 0, at x equals to 0, this is x equals to 0, our diameter is d1. At x equals to x, our diameter is dx. At x equals to L, the diameter is d2. Diameter is d2. That is here our, you can see that if we join the coordinates, here the coordinates are d1 comma 0, here the coordinates dx comma x, sorry, here the coordinates are 0 comma d1. Here coordinates are x comma dx, and here coordinates are L comma d2. If we join the coordinates, it will form a straight line. You can see that the variation between the diameter and length. Okay. So to find the slope of this curve, to find the slope of this curve, here this is our, and the slope is our theta. Okay, that slope will be, when that our slope is is uh, y2 minus y1 upon x2 minus x1. Here our y2 is d2, and y1 is d1, and upon x2 here is L minus 0. So the slope is here is d2 minus d1 upon L. Okay. So to find our is we know that our equation of straight line, that is equation of straight line is y equals to mx plus c. Here our y is dx and our slope we find out this is d2 minus d1 by L whole x, and our intercept here is d1. Okay. Intercept here is d1. Our equation we find out that is dx equals to d2 minus d1 upon L x plus d2. Okay, d1, sorry, d1 as our d2 here, d1, sorry, d2 is greater than or sorry, less than d1. Our equation of slope straight line will be dx d1 minus d1 minus d2 upon L x. This is our formula for dx. Here our dx, this is our diameter for our elemental strip. So this is the relationship between dx, d1 and d2. If we have d1, d2, and from which end, from, from left end, how much distance the elemental strip is taken, and what is the whole length of the tapering rod. If all things is given, we can find the dx. That is our diameter for the elemental strip. Okay, so here some we to find the stress, we have to find the stress. We have to find the stress now. So in the tapering rod, uh, some load P is acting here. Okay, Due to that load, some stress will be generated in the left end, in the right end, and also in our elemental strip. Okay. This is our elemental strip. Load P is acting here. Load P is acting here. Okay. This is our dx, this thickness of the elemental strip. Due to load P, some stress will be generated in the elemental strip. Sigma x is uh, P upon A. Okay. P upon A. This will be P upon pi by 4 into dx square. This is the area. Therefore, P is equal upon pi by 4 into dx square. Okay. This is our stress for the elemental strip. Okay. Stress for the elemental strip. So, due to that stress acting in the area, acting along the area of elemental strip, there will be some amount of strain in that elemental strip. Okay. Also, there will be some deformation. Due to this deformation, there will be some change in length in the change in thickness, that is change in dx in the elemental strip. The dx will be dx dash now. Dx dash now. So our change in dx here is dx dash minus dx. Okay. So our strain here is stress upon Young modulus. Okay. Our strain is nothing but change in length, change in dx upon original dx. This is p upon pi by 4 into d1 minus d1 minus d2 upon L whole x square. Okay. So our elongation in the elemental strip del dx will be p dx by pi by 4 into d1 minus d1 minus d2 on lx whole square. Okay, let us take this part as key, that is k will be d2 d1 minus d2 on L. So formula for elongation of elemental strip will be del dx is p dx upon pi by 4 into d1 minus d1 minus d2 upon L x whole square. Okay, so to find out the total elongation of the tapering rod, we have to take the, so to find the elongation of each elemental strip, each, or the total, or the total uh, total our total elongation along the tapering rod, we have to integrate the whole equation of elongation from x equals to 0 to x equals to L. From x equals to 0, 0 to L, 0 to L. Okay, so here here our constant here is p pi by 4. Oh, there is some e here, sorry. Okay. E here, and this part is k. Our constant here is p pi by 4 e, so this will be uh, move to the left side, p upon pi by 4 e 0 to L dx d1 upon kx 2. Okay, here p upon pi by 4 e this when this d1 minus kx whole square move upwards, this will be d1 minus kx whole minus 2 dx. Okay, we know that integration of xn is xn plus 1 upon n plus 1. Okay, so the integration will be upon pi by 4 e d1 minus kx minus 2 plus 1 minus 2 plus 1. Okay, give the limit 0 to L p upon pi by 4 e d1 minus kx minus 1 upon minus 1 0 to L. Okay, p upon minus pi by 4 e this will be 1 minus d1 upon kx 0 to L. Put the limit here p upon minus pi by 4 e 1 d1 minus kl minus 1 d1 d1. Okay, this is our total elongation. Okay, total extension formula for is our formula for total extension. The total extension will be total extension will be p upon pi by 4 e whole 1 minus d1 minus 1 minus d1 Oh, sorry. Here, our integration is d1. Our integration is d1 minus kx minus 1 upon minus 1, and we have to derivative that part, d1 minus kx. So our derivative here will be d1, derivative of d1 kx will be d1 is here is constant, so 0 minus k constant here will be come out, and derivative of x is 1, so here minus k will come out. So our there will be another that k will come out, and whole thing will same here, okay, only k will be there. So d upon p upon pi by 4 p k 1 minus d1 minus kl minus 1 upon d1. This is the total extension. Now substitute the k value here. K value here. P upon pi by 4 P d1 minus d2 upon L 1 minus d1 minus k that is d1 d2 upon L k minus 1 upon d1. Now here L will cut out, L will cut, and here P 4p upon pi e L, oh sorry, d1 minus d2 upon, oh here L move upwards, 1 divided by d1 minus d1 plus d2 of minus 1 upon d1. So 4pl upon pi e d1 minus d2, here d1 will cancel out, this will be 1 upon d2 minus 1 upon d1. This part will be 4pl pi e d1 minus d2 d1 d2 and d2 d1. This will be cancelled out, and the formula for extension will be, total extension will be 4pl upon pi e d2 d1. This is for when our diameter varies along the length L. Diameter D varies along length L. D2. Okay, when our diameter is same or uniform throughout the length of the rod, everywhere the diameter is D. Everywhere the diameter is D. Everywhere the diameter is D. In that case, the total extension will be 4PL upon pi E. This D1 D2 will be same. This D1 D2 will be D1 D2 will be D here. So this will be D square. Okay, that's it for today. Thank you guys.